Hi, good morning. Thanks so much for joining me in my shop here for a last shot with this radio. Now, the last video, which you may have watched, I was anxious about posting that because it was quite a runaround without too much benefit. But I decided I did so many interesting things, why not put it up there, even if they didn't seem to get me really anywhere. So, I've got this guy all back together. We're going to play him. Especially on the high band where some strange difficulties exist. And then I'm going to compare this to a similar radio of a different brand. And then lastly, I'm going to bring in this guy's big brother just to have a look-see because I haven't done any work to it. I don't know anything about it. But so this guy, I think, is just about as good as I can get it. And I've got him hooked up to an outdoor antenna here. Let's see what it does. Okay, we're on. The light is so dim in this radio, you'd never know there's a light in it. And I'm doing this at, it's just past 8:30 in the morning here, so it's a little early to be doing shortwave stuff. Hello, radio. Here it comes. Very, very slow to warm up radio. Okay, let's make sure we're on. Let's go to band 1 and just see what we hear. So this is the broadcast and broadcast band. And I don't expect to pick up any stations. We're not on the loop antenna. Picks up the interference really well. Okay, enough of that. We'll go to the top band. So we're going to start at 13 megahertz. We're going to go up and see what we get. And I don't expect to get too much. Let's see what we get. But whatever I get, I should get twice. This is a European shortwave band. It's 20-meter ham band. Northern Ohio, he said. Okay. So this radio really is intended for listening to ham radio. That's why it's got the well, it's a CW pitch, so it's maybe intended for listening to Morse code mostly. But of course, with this beat frequency oscillator, it's able to make single sideband listenable, which is what we were doing. I'm going to leave this at 50%. So we have a fine tuning this way. I'm not too worried about the accuracy of this scale. And we'll turn off the back to AM.
And it shall see the mountain is your problem.
Okay.
stop talking about.
See if we pick the same station up again, about 900
and
kilohertz higher.
confessions to it. Now, repeat this prayer for salvation with me.
900 below.
I confess I am my sin.
Look at that.
Me. I believe you sacrificed your life
It's louder here.
to secure my salvation. Jesus, come into Amen. I want to
So we're tuned to the image frequency of a station that's located down here. So that's another demonstration of the weakness in this radio. And you know, it's not surprising because the radio has no I forgot now. Does it have a front end RF2? It has a front end tuning system where it has some coils and capacitors, and then that goes right to the mixer grid. There's no front end RF2. That situation, the response curve is fairly flat, and up in this high frequency, the flat curve covers a great distance. So the image is still within the receivable part of the radio. It doesn't suppress it very much, and the only solution that I know of is to do double conversion, or to use a IF much higher, typically around 10 megahertz, and that puts the the image 10 megahertz away, which is so far away that it's going to be suppressed by the front end. Throw in an RF tube, because if you got a double conversion radio, you're going to have a good front end too, and you're getting sharper and sharper to the point where you're never going to hear an image. And that's really what you're looking for in these radios. But this is an inexpensive radio, I'm sure, in its day compared to others. So that's pretty much the demonstration right there. If we go now, so are we picking up the image or the real McCoy? This is probably the real McCoy. The image then is going to be up 900 above. Let's see if we can find it. There it is there. Now don't be fooled when you're doing this. There is some shortwave stations that broadcast two signals close together. I think Radio Marti does that. 11, I can't remember the numbers, 11.6, and again 11.8 or something like that. That's not an image. That's two actual transmissions. So there we are. Otherwise, the radio's receiving stuff. What if we go way up here? Did somebody just call my cat in here? How did he get here? Again, so you can hear all kinds of Morse code here. I've got it tuned to one spot, and we're hearing lots of different Morse code. And Morse code's at different pitches. So the radio's ability to even separate out a single frequency or a single signal, have a very tight bandwidth to do it. Doesn't have it. Can't do it. So the bandwidth or the receptive front door to this radio is pretty wide relative to trying to listen to stuff like CW or Morse code. The thing about Morse code, though, if they're broadcasting at different frequencies, the pitch will be different on here, and we can use our brain power to listen to a particular note or a particular pitch. So you could get away with it, but a good radio would have a very, very tight response curve. Bandwidth would be very small, and it would just pick out each of those Morse code signals separately. Not a good radio. It's just not a good radio. It's just no two ways about it. Oops. Although it is receiving stuff. We're up around 22. We'll go way up. 28 now. this is. I can't believe it. So we're right around 27 megahertz. This is CB radio skipping in from probably the southern states. Probably channel 6, but I don't know offhand. Yeah, I flipped it to CW for the Morse code. What happened to those stations? That's interesting. Personally, I get a kick out of listening to a CB skip from the southern United States. It's the craziest stuff, just crazy. I get a kick out of it. The problem with tuning it in on a radio like this is the transmissions are relatively short.
Hey, 243, if you got a copy, I love the audio. 243, loving the audio down here. Let's see, back out.
Wow. Somebody's got a powerful transmitter, CB transmitter in Tennessee. My guess is most of these guys have got boots on their radio. They've got extra amplifiers. And crazy stuff. But really, it's, if you want to listen to CB, get a CB radio. That's what I would say.
Working for you, my friend. Yeah, doing a fine job. That's what we do. Turn them knobs. You got her dialed in right here, right now. Just want to let you know I'm back out of the way.
And I think the guys who do this have a heck of a lot of fun doing this kind of stuff. A few years ago, skip was an unusual thing to hear, but it's not now. Now it's almost every day. I can pick up skip. Channel 6 seems to be the CB channel that most of the big guys want to sit on. Okay, I get involved in listening to the radio, and I can't let that happen here in the shop. There's another hand band way up here. Let's put the... Nobody. I have to get down and take a look. 28. We want to be around 28. Oh, you know what? I'll be down here. Right near the CB band, there's a ham band. I don't know what that is. Somebody transmitting something. Probably two signals heterodyning. You know, in a radio like this with a powerful image. I think it's all CB I'm picking up here. Okay. Oh, it's a bit of a hum in this radio. Now, we're going to compare that to this radio here. So this is a similar class of radio. This is a Gonset G-43. Well, I guess you can read G-43. I like this radio a lot. I've aligned it correctly. I don't know. So we're going to play this radio and do the same thing, go through the same band and tune around, just see what it sounds like and if we can detect this image situation with this radio. Is this a dual conversion radio? I don't think so, but it's physically bigger. First, time for a little coffee, I think. Okay, let's start him up, and while he's starting up, I'm going to give this, we're going to take a look. I couldn't find a schematic or manual. I have a manual for this. I couldn't find it in my house right now. So, but I did find this on Radio Museum. So here we are. This is the Gonset G-43. And the thing that's interesting, take a look at the number of tubes involved. Many, many, many tubes. And look what it says here. The IF frequency is 1650, not the usual 455. 1650. That's pretty interesting right there. That's enough, probably, to settle down the problem with the image frequencies. Particularly because it would push or cause the image to be so far removed from the frequency you're looking for, you're not likely to stumble across the image. It's too far away. Out of band, even. So, assuming this is true, this could be wrong on Radio Museum. Probably not, though. So that should make a difference. Let's try the radio now and see what happens. Okay, so we've got a few extra controls here too. We have a sensitivity control, which is up full. A noise limiter, which is on. I don't want that on. There's a crystal calibrator. This is a nice radio. Antenna control. Antenna tuning control. It's in receive mode, and it's receiving. Now, can you see that there's actually two bands here, and two tuning knobs, a main knob and a band spread knob. So what I'm going to set this to, I don't know where to set this. Where do you set this? We won't worry about it. I'll just leave it in the middle for now, but it should be at one end or the other. Maybe we'll sort that out as we go. We're at a low frequency here. We want to go up in band. Well, that fixed it. That fixed it. It has a tumbler system. And it's designed so you actually see it best when you look down a little bit at it. Or at least that's the way the paper rotates. Now, it was around 15 megahertz that we were finding some stuff. Here's around 15 right here. And I'm going to put this, so this is really calibrated for a 20 meter band spread. So just to show you how you do this properly, you put this to 20. And now you'd use this to go through the 20 meter band. So that's the sound of what most hams are doing these days, including me. That's FT8. That's a huge amount of fun. You don't even have to actually make interactive contacts to get a lot of fun out of FT8. If you know about the PSK Reporter mapping site, PSK Reporter. Lots of fun, but that's not what we want to listen to. I don't even have the SSB setting or the BFO switched on here. Wrong knob. How about a little Morse code? A little fast for me. I'm terrible. I've been learning Morse code for 45 years. I just acquired my first Morse code key a week ago. Is it different digital modes? I don't know what that would be. It could be slow scan TV, in fact. I'm not sure. So interesting stuff going on. Antenna, didn't try the antenna adjustment. Now, we want to do the experiment. So let's see, this is 14.5, just about exactly here. 14.5, so up at the high end is where this should be sitting to kind of neutralize its effect. Put it here. Okay, it's just bottom scale you're looking at. The upper scale is just, you shouldn't even see it, but you do. A bit higher. You gotta pick something up and then look for its image. Tricky when the signal's fading in and out to make adjustments to the radio. So this is pushing the S-unit meter right over. Doesn't sound that powerful to me, but so now we're going to look for this first 900 above, but it shouldn't be there. 900 would be up here. I think there's a stronger station in here. I want the strongest station we can find. Here we are.
For Holy Spirit, when he says he's going to bring a comforter, I've got these all written down. I took my notes out, and I want you to hear this. The word is Saterikalitos.
Saterikalitos, huh? Okay, once again, we're going 900, but there shouldn't be anything there. 900, about here. Nothing. Go back. Now we're going to go, what was it? It was 1.7, wasn't it? Let me just check and be sure what the... so the claim is 1650 is the IF. So we got to go up double that. So in other words, 1650, you get to the local oscillator. Let's check it. Let's check it. So if we're tuned in, this is 15770, I'm sure. So 1600 above that. Oh my God. Look on, these are big numbers. So we go 15770. We want to add to it the 1650. And that should tell us the local oscillator frequency, 17420. So if we tune this guy to 17420, that's what we should get. So we're going to go here, 17420. Now, is the local oscillator anywhere around here? I'll tune this a little bit. We'll see if this radio reacts. That's a metal cabinet radio. I'm going to throw the antenna at the back. Do we hear anything? There it is. Interesting sound. So there we are. So it is 1650. I don't remember that when I aligned this radio so long ago. I'll have this guy back in here at some point, probably in a few months. Okay, so now we want to try to find the local oscillator. Ignore what I just said. So we want to go another 1650 above this. Add 1650. 1970. So we might get this station again at 1970, way up here. Okay, so let's listen to it for a moment.
And then a couple died before that. At least one died just before the music.
1970. Nothing. Okay, so my imagination is telling me I'm hearing WWV in the background on this. It's right on the 20 mark too. I don't know. We go down to 15. Don't think so. So I think that's really all we need to do to compare these two radios. So this guy has solved the image problem by raising the IF frequency. If you think of radios, very early radios using the super heterodyne technique, those radios, the earliest ones, their IF was very low, 160 kilohertz. So that would present this image problem. Wow, it'd be in your face for sure at 160 kilohertz. Of course, the early days, radios didn't tune this high. Nothing was going on up here. This was all possibly high frequencies. So you know, maybe as the radio frequencies went up, this problem became more and more evident, and then finally decisions were made to standardize the IF at 455, which I think was a multi-factor decision. It's not as simple as let's pick 455. I think that was very carefully picked. And as you know, radios can be 460. I've never seen one at 450, but 455. The idea of the 5 is to make the image appear between stations higher up. So instead of the image appearing on top of a legitimate station, that didn't make sense what I'm saying. That makes the image sensitivity fall between legitimate stations. So if you hear an image, what you're hearing is between two stations. And what's between two stations? Well, ideally there's nothing there to hear. So I believe that's the reason for the 5 in 455. But you know, think about how precise everything has to be for that to work out. Okay, so I'm going to put this radio away. And actually, I put it back in my listening post because this is actually a pretty decent radio. You can cover a long distance very quickly. You can pick out the stronger stations very fast because of when you're tuning. And then it has this band spread which you can use for fine tuning and whatnot. It's actually a very nice radio. Yeah, I like it. My favorite radio, though, is a Hammarlund SP600. I'm not going to bring it in here. It weighs 65 pounds or more, and but it's a dual conversion radio. All good communications radios are going to be dual conversion. So I'm going to get this off my bench, and I'm going to bring in the next radio. He's going to get the works in here eventually, but today we're just going to take a peek at it. I'm not even sure I'm going to plug it in because I don't know its condition. We're going to get it in here anyway. This was really a demonstration of the image frequency problem with the Hallicrafters. I had another much smaller Hallicrafters in here quite a few months ago. A friend of mine owns it, and it was terrible. It was a horrible radio. Okay, I'll go get the big guy, and we'll see what we can see. Okay, I got big brother here, little brother, and baby brother. Well, I don't own baby brother. He's at a friend's house, and he would be a little bit smaller yet, sitting up on top. I put this here just for some quick comparisons. Knobs are very similar, except I've cleaned the ones up here. This guy has no meter. This guy has an indicating meter here, oddly enough. Oh, can't really see it. It's hard to see. I was going to say, oddly enough, the scale stops here, but it doesn't. It continues in red. It's just very hard to see up here. got a few controls. I don't know what they are. What is this? Look, this whole piece is a panel right in here. It's as if this is a unit, a separate unit of some sort. Missing a knob here. So, doesn't feel good. Doesn't feel good. It's either loose on a stuck shaft. No, the shaft is moving. You know, this might be BFO or something like that. That could be turning a slug in a coil. And I had another radio where I had that arrangement, same as this one. This one has slug in a coil, but it has a physical stop. You can't move the knob any farther than that. Because if you could turn the knob all the way around, you could eventually drive the slug to the end of the coil. What happens? The end of the form. What happens then is it jams, and then you rip the form. Or do something crazy like that. Or this is just a convenient way to keep you, in the ballpark, so you don't get way out. My beautiful Hammerland. One of the first things I did with it was I turned the BFO control on my Hammerland just when I got it. I got it in 1970, would have been 76, I think. And somebody previously had turned the knob hard enough to break the pin, so there was no protection. I turned the knob, got a little tight, pushed a little harder, and what I was doing was ripping all the wires away because it had gripped the coil. It was now rotating the whole coil, and I just ripped the wires off inside. I had no idea I was doing that to that radio. It's all fixed up now. But, so caution on these. So that's what this could be. Caution. And then this could be that. I don't know what these are. Standby and receive. AC off. High, medium, low. Why would they color medium red? I don't know. I guess maybe they're suggesting that medium is flat. A flat response. This is a tone control, I'm pretty sure. Down here it says pitch control. Oh, so this is the this is the control for the BFO. I don't know what these are. It'd be interesting to find this stuff out. We have band spread here, which is the same as this. Set to 0. It says right on it. Set it to 0. So it's not having any effect. And then we have the main tuning. Great big dial. There's the numbers here indicating which band. And here's the numbers here. And they've colored number 1 red. Why would they do that? Okay, number one is the AM band. Do you need it to be red to remember that's the AM band? Control feels nice. Tuning works. There's some weight behind this one. There's a flywheel behind this one. No flywheel behind this. And no flywheel, but you can do this with it. Again, I'm just comparing it to some of my older radios. Again, the Hammerland has this big tuning knob. You spin it and right across the dial. It's a thing of beauty. Volume control, sensitivity control. Very curious about these. I'd like to find out what these are before we go too much further. Headphone jack, noise limiter. There's a noise limiter on here, but the noise limiter is really trying to get rid of spiky noises. I guess that's the best way I can put it. Ignition noise is really what they were after back then. Automatic volume control, you can turn on and off. That's a great feature. I personally find listening to shortwave way better with the automatic volume control switched off, and you take control of it yourself over here. Often ruins the reading on the meter, more or less. You can't really use the meter, but allows for much more comfortable listening, because you don't get the between station noise coming out. CW, AM. I have the feeling these red colors are kind of like this is where if you can't make the radio work because you're too stupid, just flick everything to the red spot. Okay, you're just too stupid. Everything on red. And it's going to work as an AM radio. Let's find out what these are. And this panel, this unusual panel here. Well, let's spin it around. Look at the back. Oh, you know what? It's got a hinged top. We're going to open the top. So literally I'm seeing this really for the first time. You could guess this is an antenna. What's going on here? What's happening there? Somebody is taking cutters and gone kapooey on this. And what is this? This is going to the speaker, I would guess. It's a speaker plug. Meter. Down here it says meter. So this is I'm guessing this is the meter it's talking about. This must be like an additional feature. You could buy the radio with this additional feature. And if you didn't, what would be here? I don't know, postcard from Miami or something. I don't know what it would be there. Meter. So somebody has cut the meter. Well, what would be their thinking on that? Well, why would somebody do that? A little bit. Oh my gosh, look at this. Hallicrafters. Rogers Majestic Limited. So this radio is actually built by the Rogers Majestic Company. It would be probably in Toronto. Yeah, Toronto, Montreal. So Toronto or Montreal. And it's branded though. Well, who built this one up here? This one's manufactured by Hallicrafters in Chicago. Canadian representatives, Rogers Majestic Limited. What's it say exactly down here? Patented 1931-1949. 1 amp. Manufactured by Rogers Majestic Limited. Well, isn't that interesting? And what is this? Doesn't want to come out. It says, what's it say down there? Power. It says power. Here's the power. Wait a minute. Here's the power. Well, some of these radios are made. How did this get so tangled up? Some of these radios are made. Here we are. So you can run them from a car or 6-volt battery, something like that. Remember, cars back in the day had 6-volt batteries in them, not 12. Wow. Okay, so this guy has the potential to be a nice radio, to be a well-engineered, well-operating. That's some well English there for you. Let's see, it's got some screws, look like they're holding the speaker. I'll have to open this up. I'm sure it's just some kind of snap clip or something. Maybe I shouldn't squeeze here. Let me give it the... What does that sound? It almost sounds like somebody dialing a fast telephone from... Strange sounds in my shop. I have no idea what that was. So we look inside and we go, yeah, look at that. Well, it's a good thing. It's full of tubes. That's good. We don't want to open one of these and find all the tubes missing. Power transformer. So the Gonset also had a power transformer in it, but that's smaller. Hallicrafters, no power transformer, series tubes. So And look at this. 1, 2, 3 IF cans. There's the weight I was feeling out front on there. Looking at the strings. You see, it's actually when you tune the fine tuning or the band spread, you're turning this just a few plates in and out. It's like a huge trimmer is what it's like. Very good. 3 sections. The other radio only had 2 sections. The Gonset I don't know about. I suspect it also had 3 sections. So one of these is always the oscillator. If you have 1, then it's probably tuning the antenna. If you have 2, it's probably tuning the antenna or the input to the first 2, and probably tuning the output from the first 2, probably. So somebody has got their pen out and has carefully marked all the adjustments here, like C3, C15. Did they get it right? Hopefully. So, all indications of a good receiver. Very good. Very tempting to turn it on. I have no idea what's going on underneath. No idea if somebody's worked on this. Ooh, what's going on here? Oh, this is connected to. Oh, what is that? What is that? Well, this looks like 2 switches. Looks like there's a switch in here. So it's hooked up to here. There's some wires going down the chassis, but you know they're probably headed for the phone jack down here, way down here. Probably headed for the phone jack. So you're probably switching with this switch. This is a switch. That's why I was feeling so weird when I was turning it. So you've probably got silent, headphones, speaker. Gee, I don't know about that. I don't know what they've done here. So you're going to use the headphones. You want the speaker turned off. But it could be the case. Nothing's on. Nothing's on. Headphones on. Speaker on, along with the headphones. But that wouldn't matter, would it? Would it? And then these wires hanging out the back. This is for another speaker. This is no antenna connection. Antenna connection's down here on some screws. So somebody's monkeyed around a little bit with it. This looks like a replaced resistor or an installed resistor. What is this? What is this thing? Interesting stuff already. This looks to be. It looks like a transistor. It looks like a transistor right in there. But I'm sure it isn't. This looks like a connection where somebody has crimped the wires together and never soldered it. A guarantee form should be delivered to you with this receiving set. If you fail to find it, ask your dealer for it. I'm afraid I don't have the guaranteed card, so it's, I can't send it back now. Let's do one more thing. Because I'm going to do a whole video on this. I'm going to have to kind of redo this introduction here. Important. Ooh, we better read that because look at how big they put the important part there. Rogers Majestic Limited. For your protection, this receiver has been properly adjusted and sealed. Sealed at the factory. Breaking these seals without written permission from the factory or the dealer will void your guarantee. It's got the same sort of rotating plate arrangement. We just take one screw out. The screw's practically, this is not the original screw. Somebody has screwed with this thing. Pretty sure. There's no getting the bottom off, but we can open up this plate. I have to take this foot off. Do we? I don't think you should have to take that off. What can I wedge against? Don't do that. Okay, this is going to come off fairly easily. These feet are as hard as a rock. Come on, keep coming. It's like some kind of goop has been poured in here. Somebody tried to refresh these feet. They put some goop on it. You can see up here, this one's got goop. This one's not. They gooped the two front ones. This screw, what is that? That's a horrifying thing. I don't know what that is. But what I'm hoping to find out is somebody gone in here and changed capacitors and done stuff like that? But maybe that's going to be too big a deal to do today. I'm terrible. I can't stop. There we go. Lucky break. It's built in Canada. Oh, built in Canada. Uses a square head screwdriver. So people in the world have never seen something like that. A square head. It's a little hard to see on the camera, but Canadian screw. Okay, now we can lift this plate up. Oh, we just see a bunch more holes. Lots of adjustments though. Again, all labeled. Somebody took the time to label them. That tells me somebody's done those, or they wouldn't bother labeling this stuff. So this guy's been around. He's been around. Now he's coming to my world. We're going to find everything out about it. And see if we can't make this into a good receiver. Because I think this one has the potential to be a very good receiver. So we have to have good tubes, good parts, good alignment. Of course, all radios need it. Get that on there a little bit. All radios need a good antenna to work good. So there we are. Interesting. That's a good preliminary look at this radio. What is that? This band change knob has a shaft that goes all the way through the radio and is supported at the back here. You see that that's moving? You can imagine this is full of switches, wafer switches all the way through here. Good show. This will be fun. So I'm probably going to spend quite a bit of time on this guy because, as I say, this is one that's worth getting to work well because I think it's quite usable. It has all the features that make it quite usable. I didn't figure out what this is. Wait a minute, there's one more thing to look at. I'm scratching the cabinet here. So that other control, you may have noticed it. It's a potentiometer, and it appears to be associated with the meter. Some kind of meter zeroing or meter sensitivity setting with no knob on it. And this is not the original knob. Well, I don't know. This unit seems to be... Well, why did they do that? Why did they put in a non-conductive plate here for all this stuff? Why would they do that? Why not just continue the metal cabin? Must have been an option. Must be the case. Okie doke. Well, thanks a lot for watching today's video. Tomorrow we'll start on this guy. See what happens. See ya.